Okay, I've plotted my average rate of change versus my midpoint clock time, and my graph looks like this. There's a clear upward trend, as we of course expect. We expect the ball will go further every time. And these points are kind of scattered around a straight line, which I could estimate to be maybe about here. Okay, maybe that is the line, or it's close to the line. That represents the average rate of change versus time. So having marked a couple of points that appear to lie on that line, I can aim this straight edge at those points and extend it a little so it actually hits the points. Now, how did I do? Hell, there are 4 points where I was a little bit low, 3 points where I was a little bit high. The points, 3 points where I was a little bit low, 3 points above the line, 4 points below the line. The points above the line are further than the points below the line. Probably should have raised the line up a little and maybe tilted it a little differently to get the least average distance between the points and the line, which is approximately how you do a best fit line. But it's a reasonable fit to the data. So we can now determine what the linear function is. Okay, we can estimate the rise and the run of this graph between 2 points, 2 chosen points, and from the rise and the run at a point on the graph, we can determine a linear function. So let's just choose 2 points. Now you could do a similar graph and you could do this, but I'm going to, again, since the graph goes through the origin or through the y-axis, I'm going to go ahead and use this as one of my points, and then don't want to go too far beyond the end. I'm going to use this as one of my points because my scale only goes up to about 26 here. And I'm going to estimate, okay, the coordinates of this point, here's 3. The point is actually centered a little lower than that. So I'm going to say that this point is maybe 26, 2.9. And if it isn't 2.9, maybe it should have been. This point here, here's 1 on the y-axis. That looks like about half. So that point looks like it's 0.5. Now, using these points, I can estimate the slope. I've already estimated the y-axis, the y-intercept, and I'm not going to go through the details of that. We've seen that on previous videos. The rise is from 0.5 to 2.9. So it looks like the slope is 2.9 minus 2.5 over 26 minus 0. And it's 2.9 minus 0.5, 0.5, not 2.5. So it looks like 2.5 over 26, and that's pretty close to 0.1, pretty close to 0.10. And it actually, I think, rounds off to 0.10. So our equation is, we used y for position here. I'm going to use average rate of change. I'm going to call that R. Our line will then be R equals slope times T, which is 0.10 times T, and then plus the y-intercept, which is 0.5. So there's our best fit line. Again, the data are kind of scattered, so there's some uncertainty in where we should have really put the line. As I say, I think I probably should have used a little more slope, which would have gotten the line a little closer to this point, and maybe that would have run the y-intercept a little lower. But based on these intercepts, right there is the equation of our line. Now, we want to go back and do a scatter diagram for our position versus time. And gonna use another board, so we'll stop here, and we'll do that in a subsequent video.